read, you should read that, go through that, so that you can understand how structures are formed, how the clay mineral structures are formed. That is why I've sent many references for you, so that if you read, you will understand, and you need to practice writing those structures also. So that part of chemistry, when you come back again, I will explain to you on the board. Only if you write, we can understand those structures. So coming to all the structures, what I explained, tetrahedral, octahedral structures, the main two elements required for the formation of structure is, that is silicon and oxygen. So how do these structures get formed? So we know that oxygen is the dominant element, clay element found on the earth crust. So oxygen is the major anion that will coordinate with other cations to form atom structures. So major ions that occur in the earth crust will coordinate, that is coordination number, no. So coordinate with oxygen, forming different shapes or structures like tetrahedral, octahedral, cubic, triangular structures. So all these formation depends upon the ionic radii. So the ionic radii only will link the two atoms together to form the structure. So we know that you should know some of the important points, like oxygen weight is percent by weight, 46% by weight of oxygen is found on the earth crust, followed by silicon, that is around 27.72%. Third one is aluminium, 8.13%. Iron is 5%. So in your objective questions, they will ask you dash percent by weight of oxygen is present on the earth crust, means you need to write 46.60%. And that of silicon is 27.72%. Aluminium 8.13%. Iron 5%, calcium 3.63%, sodium 2.83%, potassium 2.59%, magnesium 2.09%. So total around 98.59% of the elements found on the earth crust, oxygen is dominant in nature, followed by silicon and aluminum. You should remember that. Even by volume, oxygen occupies the highest. So these atoms are packed together or coordinated together by larger anions like oxygen, and this depends on the radius ratio of cation to anion. Ratio means R is radius, C is cation, A is anion. So RC by RA gives you the ionic radii. And the coordination numbers also are got by the amount or the valency of charges present on the atoms. So because of that only, you in the last class itself, I have given you various structures to you, like that's individual sorosilicates, double chain silicates, then neosilicates, cyclosilicates, inosilicates, all that you have already must have seen in the links what I have sent to you. So all these depend upon the ionic radii and coordination number to form respective clay mineral structures. So you have to read first, you go on reading all that so that I can explain when you come back on the board. So that structures part again I will repeat in the class because it is important. The next part is I will tell you which is you can understand. So that next part in your syllabus is source of negative charges on silicate clays. The structural part again I will repeat. I've sent the link. You go have to read that. That is why I'm not explaining that part here. Only after you read, I will explain that so you can understand. We need to write on the board and only then it will be easy for you to understand how that sharing happens, how that bond is formed. So the next topic is source of negative charges on the silicate clays. So we say clay is negatively charged and it will attract cations. So how do you think negative charges arise on this clay complex? So generally there are two types of charges. You should remember two types of charges. One is pH dependent charge and other is pH independent charge. So pH dependent means it will depend upon the H plus ions present in the clay mineral. That is pH dependent. pH independent means it gets originated from exposed crystal surfaces, that is ionizable hydrogen ions, and by isomorphic substitution. Isomorphic substitution means substituting one ion with another ion which has similar ionic radii. First one, how charges develop on the exposed crystal edges. See, the negative charges on the silicate clays develop due to unsatisfied valencies. You see oxygen minus, we say O minus or 3 minus, all anions. These anions develop negative charge due to unsatisfied valencies at the broken edges of the silica and aluminum sheets. The flat external surface of the silicate clay minerals also serve as source of negative charge. The ionizable hydrogen H plus ions, which are dissociated from hydroxyl ions, H2O only, H plus will get separated, OH minus ions will get separated on the clay surfaces. So in the clay, because aluminum and silicon is present, the Al will get linked with OH ions, aluminum hydroxide ion or silicon hydroxide ion. That OH portion, OH minus, OH portion of the clay will get ionized and it leaves a temporary negative charge on the oxygen. So the reactions are like silicon hydroxide will be formed when OH minus ion comes in contact with it. H plus will come out, leaving SiO minus ion on the edge. So that is how a negative charge is formed on the silicate mineral. Similarly, Al, OH plus OH, OH will come out, leaving AlO minus. So this extent of ionized hydrogen depends on the pH of the solution. More ionization occurs in more alkaline solutions. Alkaline means OH will be there. Wherever hydroxyl groups are there, more negative charges will get developed in such clay minerals. The magnitude of this pH dependent charge, it varies with the type of colloid. So this type of charge depends upon organic nature of the colloid. So that is pH dependent charge and depending on the ionizable hydrogen ion concentration. How another mechanism helps in development of negative charges on the silicate clays is isomorphic substitution. Isomorphic substitution, I told you, it is the replacing ions of similar radii. So isomorphic substitution is the substitution of one ion for another of similar size having lesser positive valence. Example, Si4 plus is replaced by Al3 plus. See, Si4 plus is a higher valency ion 4 plus, but that can be replaced by a smaller valence ion like Al3 plus. And sometimes more replacement of Al3 by either Fe3 plus also. See, Al3 plus is almost equivalent to the radii of Fe3 plus. Fe3 plus, then Fe2 plus, Mg2 plus, then zinc 2 plus. So all these ions can be replaced with each other because they have similar ionic radii at the edges. So without substitution, the positive and negative energies are in balance. So the three positive charges of Al, that is Al3 plus, get satisfied fully by equivalent three negative charges from the surrounding oxygen or hydroxyl ions. See, Al3 plus, when it comes in contact with water or anything, it will form AlOH taken thrice, that is aluminum hydroxide. So there is no net, it gets balanced. So no net negative or positive charge. But when a magnesium means 2 valence, Mg2 plus, ion of the same diameter as an aluminum ion, that is Al3 plus, replaces one of the aluminum by isomorphic substitution, an imbalance occurs because Al3 plus and Mg2 plus, 3 plus and 2 plus, 1 will be short. So therefore, the aluminum octahedral sheet will get a negative charge for each Mg2 plus if aluminum gets substituted there. So in a similar way, the negative charge develops due to isomorphic substitution in silica tetrahedral sheet. So even this we need to draw and explain to you. So the charge arises from isomorphic substitution are not dependent on pH. Therefore, these charges are referred to as permanent or pH independent charges. So you should remember sources of negative charges on silicate clays are developed due to pH dependent charges, pH independent charges, then isomorphic substitution. Then coming to anion exchange, some clay minerals exhibit positive and negative charges. So this is caused by anion exchange of ions between hydroxyl ions and anion ions like phosphate, sulfate, and chloride. So these are the two mechanisms of development of charges. So in the future classes, when you come here, I will repeat this. It is very difficult for you to understand sometimes. We need to practice that. So this completes your silicate clays here. Organic colloids. Organic colloid, you know, that is humus. So the charge of humus is also pH dependent. That is because humus is the end product of organic matter decomposition. Many acids will be formed, organic acid will form. Therefore, under strongly acidic conditions, hydrogen is tightly bound and it is not replaced by other cations. So, humus will have or it will exhibit a negative charge. So that is how the charges get developed on the clay surface. So when these charges get developed on the clay surface, the ion exchange mechanism occurs. Ion exchange means the reverse process by which cations and anions are exchanged between the solid and liquid phases. Sometimes ion exchange takes place between two solid phases if they come in contact with each other. For the exchange of cations and anions, the term generally used is cation exchange capacity and anion exchange capacity. And how these ion exchange mechanisms takes place means by adsorption and absorption. So what is adsorption? In the first class itself, I've told you adsorption is a phenomena by which an increase in concentration or accumulation of ion species on a solid occurs due to ion exchange of other reactions. That is surface absorption. Desorption means removal of ions by the adsorbed ion species. So for these two types, that is chemical and physical processes, are involved in this ion exchange phenomena, which includes weathering of minerals, nutrient absorption by plants, swelling and shrinkage of clay, and leaching of electrolytes. This ion exchange, particularly cation exchange, is considered as the most important process in soils, which are very much essential for nutrient uptake by the plants. So that is ion exchange phenomenon. That is reversible process of exchanging cations or anions between solid and liquid phase or solid-solid phase. So where does this ion exchange take place? The site of ion exchange. The ion exchange property is in soil is entirely seen to take place on the clay and humus. So the colloidal material of the soil, which has very less diameter, effective diameter less than 20 microns, is the important site for the ion exchange to take place. The soil particles are amphoteric in nature, means it can either be acidic or basic. Therefore, it can absorb both cations and anions. It is also observed that the charge density and potential are very high in these clay particles at the edges and corners of the silicate clay minerals present in the soil. Therefore, exchange takes place at the edges. So the ion exchange takes place at the edges of the silicate clay minerals. Then what are the kind of exchangeable ions? So the electrical charge on the soil particles is neutralized by equivalent amount of oppositely charged ions called as exchangeable counter ions, which are held to the surface mainly by van der Waals forces or Coulomb forces. Most of the soils have cations like Ca2 plus, Mg2 plus, H plus, K plus, Na plus, NH4 plus. All these pluses are cations. Among all these cations, calcium ion is the dominant exchangeable ion. Example, in strong acidic soils means H plus ions and aluminum ions will be more in number. Therefore, this aluminum hydroxide acts as a dominant exchangeable cation with calcium. That is acidic soils. In alkali soils, sodium ion will be dominant and the anions are sulfate, SO42 minus, Cl minus, bicarbonates. So these are the anions and cations which are present in the soil and undergo ion exchange mechanisms. So two types of ion exchange mechanisms are there: cation exchange capacity, anion exchange capacity. So cation exchange capacity is defined as the total sum of all the cations present in the soil which gets exchanged between two phases in the soil is cation exchange capacity. Anions is the total sum of anions which are get exchanged on the clay complex. And the total amount of this cation exchange capacity Hello? There's some problem in this network. I don't know, some power problem and all is there. You can hear me, no?
Yes, ma'am.
Okay. Some problem is there today. I don't know what is the problem in this. Okay, anyway, I will stop here. It's 12:40, no? So you take the attendance here, Gabi. You take the screenshot.
Ma'am, ma'am.
Okay, you send it to me anyway. Okay, so that I'll stop today's class. Saturday again I will take. Before that, if you come here, it is better than online because there is so much to write.
From Monday, offline, ma'am.
Yeah, that will be better because so many reactions and all. Only if you write, you can understand. And
Yes,
this is
ma'am.
difficult. I hope you come back on Monday.
Yes, ma'am.
So that I will repeat again all the structures and also it will be easy for you.
Okay, ma'am.
Okay, then I'll close the meeting. So it's
okay.
There is low battery power in my mobile also. It's getting switched off now.
Okay.
Okay, fine. You can leave.
Thank you, ma'am.
Okay, bye.